Welcome back, listeners. In our last episode, we explored how deep learning evolved over time, powering groundbreaking advancements in healthcare, space exploration, and finance. We talked about the impressive commercial applications of AI and how these networks are transforming industries across the board.
That's right. And today, we're diving into a pivotal chapter in AI's history, 2011 to 2023, a time when AI truly started to rival human capabilities in key domains.
This was the era where we witnessed the rise and fall of IBM Watson, the emergence of generative adversarial networks, diffusion models, and the spectacular rise of deep learning networks like transformers. These breakthroughs marked a major leap in what AI systems could achieve.
And we'll also explore some of the key domains where AI has made remarkable progress, like language processing, image generation, and even creativity. We're drawing insights from the Fourth Industrial Revolution and 100 Years of AI, 1950-2050, by Dr. Alok Agarwal, a fascinating book that's been guiding our journey through AI's evolution.
So buckle up as we explore how these advancements are reshaping our world and pushing the boundaries of what AI can do. Let's get started.
If you think about it, 2011-2013 was really a fascinating period. It kind of marks the beginning of what a lot of people call the Fourth Industrial Revolution, where digital technology is starting to blur the lines between the physical world and the digital world.
One of the best examples of AI making waves was IBM's Watson supercomputer, taking on and defeating two Jeopardy champions back in 2011. Imagine this, 90 computers working together, delivering the equivalent brain power of 4,000 humans focused on trivia.
And it didn't just win, it dominated. Watson racked up over $77,000 in winnings, and even Jeopardy champion Ken Jennings joked after the game, "I, for one, welcome our new computer overlords."
That was such a huge moment. Everyone was talking about it. But here's the interesting part. Watson didn't win by using some groundbreaking futuristic algorithm.
Exactly. It relied on a fairly straightforward technique called logistic regression.
Which is a good reminder that AI progress isn't always a straight upward trajectory. There have been periods, what we call AI winters, when research and funding slowed down. But even then, progress continued quietly in the background. Then, out of nowhere, you get something like Watson proving that AI can handle incredibly complex tasks, even without cutting-edge methods.
So how did Watson pull off being a Jeopardy master?
It all came down to data. Watson was trained on an enormous collection, Wikipedia, dictionaries, encyclopedias, and even movie scripts. But the real secret was feature engineering. The IBM team figured out that many Jeopardy answers are essentially Wikipedia titles, so they tailored Watson's training around that type of data.
So it's like giving Watson a really clever cheat sheet.
Exactly, like teaching a student to focus on the most important clues.
But even with all that data and clever engineering, Watson wasn't actually understanding the information. It was great at spotting patterns and facts, but it couldn't grasp the subtleties of language or apply its knowledge to complex, real-world scenarios.
Which might explain why Watson's impact faded.
Exactly. IBM had big plans to use Watson in areas like healthcare, especially cancer research. But the challenges turned out to be far more complicated than expected. In the end, IBM had to scale back those ambitions and even sold off part of their Watson Health business in 2022.
So it's kind of a cautionary tale about overhyping AI.
In a way, yes. Watson's Jeopardy win may have faded, but it sparked significant progress, especially in question-answering systems. While Watson's star dimmed, a new AI revolution was brewing: deep learning.
Deep learning. I remember hearing about AlexNet dominating an image recognition competition. That felt like a turning point. AI went from understanding text to interpreting images.
Exactly. And soon, even more powerful networks emerged, like generative adversarial networks, GANs, diffusion models, and transformers. These are the driving forces behind many of today's AI breakthroughs.
So, what makes these new tools so special?
They're game-changing because they can create entirely new content, realistic images, convincing text, even art. Think about those deepfake videos. GANs make that possible. AI has moved from simply recognizing patterns to generating entirely original outputs.
That's a huge leap. But how does this impact the real world?
You probably interact with AI every day without even realizing it. Personalized recommendations, virtual assistants, and more. Beyond that, advancements in computer vision, natural language processing, and creative AI are reshaping industries.
It's incredible to think all this has happened in just over a decade.
And the pace of innovation is only accelerating. Since 2011, research papers and patents in AI have skyrocketed. It's clear the field is only growing more dynamic.
So we've covered Watson's legacy, the rise of deep learning, and these groundbreaking AI tools. But for listeners wondering how this affects their daily lives, what's the takeaway?
Let's start with something simple: unlocking your phone with facial recognition. That's AI in action, using computer vision to identify your unique features. Or think about the personalized recommendations you get on streaming platforms or online stores. That's AI predicting your preferences based on past behavior.
And don't forget the voice assistants we rely on. Hey Siri, set a reminder. Alexa, play my favorite podcast. These tools use natural language processing to understand and respond to our commands.
Exactly. AI has even moved into art and creativity, generating stunning visuals, composing music, and even writing poetry. It's blurring the lines between human and machine creativity in ways we couldn't have imagined just a few years ago.
It's remarkable how AI has become this almost invisible force shaping our lives. But if it's come this far in just a decade, where could it be in the next 10, 20, or 50 years?
That's the big question. Some envision AI tackling global challenges like climate change or disease, while others worry about AI surpassing human intelligence and the risks that might bring.
We've seen the sci-fi movies, and let's just say the outlook isn't always rosy. But what are some realistic possibilities for AI's future?
While predictions are tricky, the impact of AI is certain to grow. We'll see more advanced applications in healthcare, transportation, and personalized education.
Personalized education is an exciting thought. Imagine AI tutors customizing lessons to each student's needs and learning style. It could completely change how we teach and learn.
Absolutely. And that's just one example. Think self-driving cars navigating with precision, or AI-powered medical devices diagnosing diseases more accurately. The possibilities are vast.
It's both exciting and a little daunting. But with all this progress, are there still areas where AI struggles compared to humans?
Definitely. AI still lags in common sense reasoning, emotional intelligence, and creativity that goes beyond replicating patterns.
So while AI can win at chess or mimic Shakespeare, it can't grasp why a joke is funny or truly empathize with human emotions.
Exactly. And those are the challenges researchers are focusing on now. Solving these would mark a major breakthrough.
It's a reminder of just how complex the human mind is. We take these abilities for granted, but replicating them in machines is no small feat.
That's why the future of AI isn't just about technological progress. It's about designing systems that complement human strengths and help overcome limitations.
On a practical note, for those curious about diving into AI, where should they start?
There are so many resources out there: online courses, tutorials, open source projects, and vibrant AI communities where you can connect with experts. If you're technically inclined, learning Python is a great first step.
And if coding isn't your thing, there are still plenty of ways to engage with AI. Reading books and articles, attending webinars and conferences, even just following AI experts and organizations on social media, all of these can help you stay informed and be a part of the conversation.
Exactly. The key is to be curious, ask questions, and don't be afraid to dive in and explore. AI is such a rapidly evolving field, and the more people we have engaged in understanding its potential and its challenges, the better equipped we'll be to shape its future.
That's what we're all about here at The Deep Dive. Absolutely. Empowering you with the knowledge and insights you need to navigate this ever-changing world. We've covered a lot of ground today, from Watson's Jeopardy victory to the rise of deep learning and the mind-blowing capabilities of AI today. But as we've seen, the journey of AI is just beginning, and it promises to be a fascinating one.
Indeed. And as we move forward, it's crucial to remember that the future of AI is not predetermined. It's being shaped right now by the choices we make, the research we conduct, and the conversations we have.
So if this deep dive has sparked your curiosity, don't let that spark fade. Dive into those research papers, read those articles, and most importantly, start asking questions. What are the potential benefits and risks of AI in your field? How might AI shape the future of work, healthcare, education, or even art?
Remember, the future of AI is a collaborative effort. It's up to all of us to ensure that AI is developed and used in a way that benefits humanity as a whole.
Exactly. And in this next segment, we're going to dive into a pivotal moment in AI history when deep learning truly made its mark on the world.
It's a fascinating story, a real-world competition that reshaped how computers see and interpret images.
Exactly. Picture this. It's 2012, and a competition called the ImageNet Large-Scale Visual Recognition Challenge, or ILSVRC, is making waves. This wasn't just any contest. It involved a massive dataset of over 1.4 million labeled images spanning 20,000 categories.
And the challenge wasn't just identifying what was in the picture. It was about specifics. What kind of dog is this? What else is in the scene? It was a huge leap for AI.
How did they measure success in such a complex competition?
They used something called top 5 and top 1 error rates. For example, if the AI was shown a picture of a cat and cat appeared in its top 5 guesses, it scored a point. If cat was the first guess, it scored even more.
So it rewarded confidence and accuracy. Clever.
Exactly. And that's where AlexNet came in. Created by Krzyzewski, Sutskever, and Hinton, AlexNet didn't just win. It crushed the competition with a top 5 error rate that was 10.8% lower than the second-place AI.
That's a massive leap. What made AlexNet so special?
Its secret weapon was a convolutional neural network, or CNN. CNNs are tailor-made for analyzing images. They break an image into smaller parts, analyze patterns like edges and shapes, and then piece everything together to understand the full picture.
So it wasn't looking at the whole image at once?
No, it analyzed the details first, then made sense of the whole, much like how human vision works.
I've heard AlexNet had something to do with its depth. What did that mean?
Depth refers to the number of layers in the network. AlexNet had many hidden layers, allowing it to process information in more complex and nuanced ways.
More layers, more brain power.
Exactly. But with greater complexity comes a need for more computing power. That's where GPUs came in.
GPUs, the tech behind realistic video games, handled the heavy lifting?
That's right. GPUs are designed for parallel processing, so they can manage the vast number of calculations required for a deep learning model like AlexNet.
It's amazing to think how a combination of smarter algorithms and better hardware revolutionized AI image recognition. So, GPUs gave AlexNet a serious speed boost.
Definitely. Researchers knew as early as 2006 that GPUs were faster than CPUs for this kind of work. But AlexNet really showcased their potential.
So they thought, let's push GPUs to their limits and win this thing.
Exactly. That win created a ripple effect across AI. Suddenly, everyone wanted GPUs for their projects. It was a major turning point.
With this intense competition, a groundbreaking AI system, and smart hardware usage, where does AlexNet fit in the history of AI?
AlexNet's victory really marked the arrival of deep learning networks, DLNs.
Like their official debut?
You could say that. Before AlexNet, DLNs were interesting, but many weren't convinced they were the future of AI.
So AlexNet changed minds.
Totally. After their performance at ILSVRC, deep learning grabbed everyone's attention.
No wonder their research paper is so influential. It's been cited over 80,000 times. What made it groundbreaking?
They showed the importance of depth in convolutional neural networks, CNNs. By increasing the layers, they significantly improved accuracy.
So more layers, better results?
Exactly. That was a major breakthrough and paved the way for advancements in computer vision.
Thanks to AlexNet, deep learning became more than just a cool idea. It was ready to revolutionize everything.
Right? And we're still seeing its impact. But let's break down this idea of depth. What are these hidden layers actually doing?
Think of it like solving a puzzle. The first layer might detect edges and lines, the next combines them into simple shapes.
So, it gets progressively more complex.
Exactly. Eventually, deeper layers recognize patterns and features until the network comprehends the entire image.
Like a team of specialists, each layer focuses on a specific clue, working together to solve the image.
Perfect analogy. AlexNet proved that depth is key for truly understanding visual information.
It's not just about seeing, it's about comprehending on a deeper level.
That depth of understanding is what made AlexNet so accurate in the ImageNet competition.
It wasn't just recognizing objects, it was truly understanding what was happening in those images. One competition, a brilliant team, and the smart use of GPUs, and they changed AI history.
It makes you wonder what other innovations are out there waiting to be discovered.
Absolutely.
Okay. So ripple effects of AlexNet?
How did that single event shape the AI landscape we see today?
It's remarkable. One competition, one breakthrough moment had a profound and lasting impact. It was like a shot heard around the world. For AI.
Love that analogy. For those who aren't AI experts, how has AlexNet shaped the world around us?
Think about AI in self-driving cars, facial recognition, personalized recommendations.
Like Netflix suggesting shows I'd like?
Exactly. Or AI helping doctors with medical diagnoses. Many of these advancements stem from AlexNet's breakthroughs in computer vision. Even things like Instagram filters or Snapchat effects owe a debt to AlexNet.
So AlexNet proved that deep learning networks, DLNs, could achieve incredible results, sparking a wave of innovation and investment.
Exactly. It's amazing that a competition could drive such a massive leap forward.
It shows how challenges push boundaries, but also that progress in AI isn't just about theory, it's about applying ideas with the right tools. AlexNet had both, an innovative CNN architecture and the power of GPUs. That combination made the leap possible.
A perfect storm of innovation and opportunity. It makes you wonder what other breakthroughs are just waiting for the right moment.
That's the beauty of scientific exploration, constantly pushing boundaries and uncovering new possibilities. Who knows what the next decade will bring for AI?
So, after its groundbreaking moment, what happened to AlexNet? Did it fade into obscurity?
Not at all. Its influence goes far beyond that victory. The principles and techniques AlexNet introduced are now fundamental to computer vision.
So even if AlexNet isn't winning competitions anymore, its legacy lives on in today's AI systems. The depth of understanding AlexNet brought to the ImageNet competition is what made it so revolutionary.
Exactly. It wasn't just recognizing objects, it was truly comprehending the images. One brilliant team, a smart use of GPUs, and a pivotal competition changed AI history.
It's amazing how one breakthrough can spark so much innovation.
Totally. AlexNet's architecture and problem-solving approach laid the groundwork for countless algorithms and models. Researchers built on that foundation, leading to even more powerful and efficient systems.
It's like AlexNet planted a seed that grew into a forest of possibilities.
Perfect analogy. That one moment in time still ripples through AI today, showing the lasting power of good ideas and smart engineering.
This deep dive has been eye-opening. Learning about AlexNet's pivotal moment and its impact highlights both human ingenuity and AI's incredible potential to shape the future.
It's remarkable how much progress has been made in just over a decade. Self-driving cars, AI-powered medical diagnoses, what seemed like science fiction is now part of everyday life.
If AlexNet was such a leap forward, what breakthroughs might be just around the corner? It's exciting, but also daunting.
The pace of innovation in AI is only accelerating.
True, but it's not just about algorithms. AlexNet's success also depended on hardware. Those GPUs made it possible.
Exactly. Hardware will play a huge role in future advancements. Specialized AI chips and new technologies will enable systems we can't even imagine today.
It's not just about raw power, though. Innovative algorithms inspired by AlexNet will also be critical to tackle complex challenges.
So, it's both powerful hardware and smart algorithms working together.
But with great power comes great responsibility. As AI becomes more advanced, we need to focus on ethics and ensure it's used for good.
Absolutely. We need to think carefully about the consequences of the technology we're building and prevent misuse.
The human element is key. AI should benefit everyone, and the future of AI is something we're actively shaping.
Well said. Reflecting on AlexNet's story shows how a single challenge can ignite a revolution.
It all started with one breakthrough, a spark of innovation that transformed computer vision and set off an ongoing revolution.
And it reminds us to never underestimate the power of a good challenge to inspire new discoveries.
Couldn't agree more. Who knows what other breakthroughs are waiting for the right minds and the right tools to come together. And, speaking of breakthroughs, let's dive into how AI is revolutionizing the world of image generation. Two techniques at the forefront of this change are generative adversarial networks, GANs, and diffusion models. These methods are teaching computers to be creative, producing images that could easily pass as human-made.
It's truly incredible how far these techniques have come in a short time. While both are powerful tools for creating realistic images, they take very different approaches to achieve their results.
Let's start with GANs. They work like a competition between two players, a generator and a discriminator. The generator tries to create fake images, while the discriminator evaluates them, distinguishing the fakes from real images.
It's like a counterfeiter trying to create undetectable fake bills, while a detective keeps improving their ability to spot them. The generator learns from the discriminator's feedback, improving its images over time.
Exactly. This back-and-forth process helps the generator create increasingly realistic images. But training GANs isn't without challenges. It's a delicate process that often requires fine-tuning to prevent the networks from getting stuck in a loop or failing to improve.
Right? Stability in training is a big issue. To address this, researchers have developed techniques like deep convolutional GANs, DC GANs, which use convolutional neural networks for better image processing, and conditional GANs, which allow for more control by incorporating inputs like text descriptions.
These advancements are driving progress in GAN-generated imagery, with applications ranging from enhancing image resolution to generating realistic faces for games and creating data for training AI systems like self-driving cars.
And it's not just about making visually stunning images. GANs are also used to fill in missing parts of images and create entirely new ones based on specific criteria.
Fascinating. Now let's move to diffusion models, which approach image generation from a completely different angle. These are inspired by the concept of adding and removing noise, almost like a thermodynamic process.
Picture an image gradually becoming pure static as noise is added. A diffusion model learns to reverse this process, reconstructing the original image by denoising it step by step.
So instead of generating an image from scratch like GANs, diffusion models start with chaos and bring order to it. That's a remarkably different approach.
It is, and it has its advantages. Diffusion models are generally more stable during training and often produce images with exceptional detail and quality.
Does that mean diffusion models are better than GANs? Are they the future of image generation?
Not necessarily. Each technique has its strengths and weaknesses, and the choice depends on the application. GANs excel in certain areas, while diffusion models perform better in others. Researchers are actively exploring ways to combine their strengths for even greater innovation.
It's amazing to see how these advancements are reshaping the field of AI. With such rapid progress, it's exciting to imagine what the next wave of breakthroughs in image generation might bring.
Exactly. GANs might excel in some tasks, while diffusion models are better suited for others. Researchers are also exploring hybrid approaches that combine elements of both to harness their strengths.
That makes sense. But stepping back, what are the broader implications of AI creating images that look indistinguishably real?
It's a fascinating question. AI's ability to generate realistic images challenges our understanding of art, creativity, and authenticity. It blurs the line between reality and artificiality, forcing us to reconsider what we value in creative expression.
And it raises some critical ethical questions. Could this technology be misused to spread misinformation or fabricate evidence?
Unfortunately, yes. Hyper-realistic AI-generated images could easily be weaponized for misinformation, requiring us to develop methods to verify authenticity, especially in fields like journalism, legal cases, and public discourse.
It's clear that alongside its creative potential, there's a responsibility to use this technology wisely. It's also a reminder that digital literacy skills need to evolve to meet these new challenges.
Absolutely. We must learn to assess the source and context of digital content critically and remain aware of the potential for manipulation.
Beyond the risks, what about the positive implications? How can this technology be used for good?
One of the most exciting applications is creative exploration. Artists and designers can use AI to visualize concepts, experiment with styles, and push the boundaries of their imagination. It's not about replacing human creativity, but augmenting it.
That's a great perspective. What about practical applications beyond the arts?
In medicine, for example, AI enhances imaging technologies, helping doctors detect subtle abnormalities in scans. It can lead to earlier diagnoses, more personalized treatments, and improved patient outcomes.
And in security,
AI can analyze surveillance footage to detect unusual activity or identify individuals with high accuracy. It's also being used to create realistic simulations for training emergency responders, allowing them to prepare for complex scenarios safely.
So this isn't just about generating visually stunning images, it's about transforming fields like healthcare, security, and design.
Exactly. AI's ability to create and analyze images is solving real-world problems, pushing the boundaries of what's possible, and giving us new tools to understand and shape the world around us.
It's both exciting and a little daunting, this incredible power in the hands of humans. Where does it all lead?
That's the question we'll continue to grapple with as AI evolves. It's a journey filled with immense potential and significant ethical considerations. How we guide its development will determine its impact on society.
We've covered a lot today: how GANs and diffusion models work, their applications, the ethical challenges they present, and their broader implications for creativity and society. But it's impossible to talk about AI without asking deeper questions about what it reveals about us.
Exactly. The rise of AI forces us to confront what makes human creativity unique. Can machines truly replicate our emotional depth, our lived experiences? Or is there something intangible about human art that AI can never fully capture?
Some argue AI is just a tool, reflecting and remixing the data it's trained on. Others suggest that studying AI's approach to creativity could teach us something about our own processes.
Maybe instead of viewing AI as a competitor, we should see it as a collaborator. Together, humans and AI can push the boundaries of creative expression, achieving things neither could do alone.
That's a powerful perspective. It reminds us that AI, no matter how advanced, is still a tool. It's up to us to use it responsibly and ensure it serves humanity.
And that's the key takeaway. AI's potential is vast, but so is our responsibility to shape its development.
With this, we come to an end of today's deep dive. We explored the mechanics of GANs and diffusion models, their transformative applications, and the ethical and philosophical questions they raise. From creative collaboration to ensuring digital literacy, the conversation highlighted how AI is reshaping our world and challenging us to define our role in it.
In the next episode, we'll continue our deep dive into AI's rapid evolution, discussing the spectacular rise of deep learning networks like transformers, the key domains where AI systems have achieved remarkable improvements, and the explosive growth of AI research publications. Join us as we unravel the next chapter of this incredible journey.